Welcome to the Muscular System. The aim of these tutorials are to build a foundation of knowledge of the muscular system. So what we're going to be doing is in some respects, we'll be covering a lot of different things, but we aren't going to go into huge amounts of depth on each of them. But what we do want to do is just get a good foundation and basic overview of the muscular system. So some of the things that we're going to be learning is understanding the structure of a muscle. We're going to learn muscle fiber types, muscle attachments, muscle properties and actions, muscle origins and insertions, and then we'll look at the muscles of the body. But before we do that, I just quickly want to overview the muscular system and to say there are three different types of muscle in the body: skeletal muscles, cardiac muscles, and smooth muscles. So obviously skeletal muscles are the ones we're going to be focusing on. Cardiac muscle is the heart and or circulatory system, hearts and arteries, and then the smooth muscle are the an example of it is the small intestines. Obviously, as I've mentioned, we're going to be focusing on skeletal muscle function. They are the muscles that move the body, and they're the ones that we most are aware of, responsible for both voluntary movement and reflex movements as well. They also generate heat and maintain posture, which is a big part of the reflex movements or unconscious reflex movements. Now we're on to point number one, which is the structure of a muscle. So we're going to start in some respects at the largest level, and then we're going to work our way down into the smaller levels of the muscle, and we're going to be using these two diagrams to do so. So what we've got to start with, obviously, is the entire muscle that you can see in this image over here. Now, the entire muscle is obviously this section, and it is joined to a bone, which is here, via a tendon, which is here. So we've got the tendon there joining the muscle to the bone. Now, when the muscle contracts, this tendon holds the muscle to the bone and then allows movement to take place at the joint. As you find out, there is another form of muscle attachment, but we'll talk about that later on. But for now, muscle is joined to bone via a tendon. What we've then got is a sheath that goes around the entire muscle. So it goes all the way around the outside, and the best way I can describe this is it's like cling film or cellophane, which is basically for want of a better way of describing it, it's like a wrapping around it, and it's there to offer additional compression to hold the muscle in place, which is going to then aid the strength of the muscle and how it contracts. But when we talk about the fascial system, we'll look more at the fascia, and that's known as the epimysium, which is essentially it's a fascial sheath. What then happens is the entire muscle is made up of bundles. And these bundles, you can see obviously on the screen, are here and here, for example, and they are known as a fascicle or a fasciculi. Now, these are surrounded by another fascial sheath, which in some respects is doing the same thing, just on a smaller level, known as the perimysium. So again, it's there to hold these fasciculi together to aid the contraction, to help sort of give compression or additional compression around the muscle to aid the muscle contraction and aid the strength of the muscle. We can then break it down again into another bundle. And what we've got here is the fascicle or fasciculi is made up of muscle fibers, and these are surrounded by endomysium. So we've got these fasciculi here, surrounded by the perimysium. Then you've got the muscle fibre here, surrounded by the endomysium. So we've got 3 different types of fascial sheath surrounding each compartment or component of the entire muscle, which is, again, in some respects, all to do the same job, holding it together, offering extra compression to aid the contraction, and in some respects build the strength of the muscle. Now, these aren't, in some respects, individual sheaths. They are all the same material, just at a different level. They are all fascia. They are all connected because they weave in and out through the muscle. It's just we have broken them down for descriptive purposes into epimysium, perimysium, and endomysium. What we then get after the muscle fibers, so the muscles are wrapped in the smallest and final sheath called the endomysium, and they are made up of individual myofibrils. Now, these myofibrils on the inside of the endomysium is a layer called the sarcolemma, which contains a fluid called sarcoplasm. Now, the sarcoplasm, they contain many different organelles. We won't go into them all right now, but what they do offer is the inside it's a network of channels called sarcoplasmic reticulum, which is a storage site for calcium, which is involved in the muscle contractions. What we then get are these components here, which are known as sarcomeres. So, sarcomere. Now, this is the contractile part of the muscle. So again, we've got all labels here. We're not going to focus on all of these labels, but all you really need to know are the Z line, which will be back here. You've then got the thin actin filaments, which are all these blue ones, all the way down through, here, 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 and on the other side, here, 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 and here. So they are known as your actin filament, which is here. What you've then got on the inside of that is your myosin. Obviously, you've got the myosin heads, and they attach to the actin. And in some respects, they pull the actin towards each other, so you get into the contracted state. This would be the relaxed state, where it's far apart, so muscles are lengthened, and then you've got the contracted state where they're pulled together. But they are pulled together by these myosin heads that bind onto the actin and pull it together. So that is the muscle from the biggest level, or the largest level, all the way down into the deepest level. So we've got our different fascial sheaths, we've got our different components, and we've got the contractile part of the muscle, which is the thin actin, thick myosin, and it's the myosin that pulls the actin together. And to complete the structure of a muscle, we're going to look at some fiber types. Now, we're going to keep it simple. We're going to go slow twitch, and we're going to go fast twitch. Now, these are basically opposites to each other, and they perform different roles within the body. So we've got structural features of slow twitch. So we've got small diameter, large myoglobin, high mitochondria, many capillaries, and they're red in colour because of that higher blood content, and there will also be a greater oxygen, in some respects, content of these. So obviously, as I've mentioned, the functional features is the increased oxygen, low force production, long-term contractions, and they are resistant to fatigue. So activities that we would be talking about would be stabilizing joints, maintaining posture, and also there's more endurance to them because of the high blood and high oxygen content to them, and the fact that they're resistant to fatigue as well. So they will work at lower levels of activity, such as walking, for example. But main big roles of them is the stabilizing of joints and the maintaining of posture. So they're going to be working with the smaller, or they're going to be more prevalent in the smaller, stabilizing, posture maintaining muscles of the body. What we then come on to are the fast twitch or type 2 fibers. Now these are in some respects the polar opposite, but there is a scale to it. So you've got large diameter, smaller myoglobin, lower mitochondria, reduced capillary content, and they're more white or pale in colour because of the lower blood content of them. So they have reduced oxygen delivery, high force production, short-term contractions, and that should be less resistant to fatigue. So there's more fatigue will happen quicker within them. So these are more force production and movement based. So they will take care of jumping, sprinting, running, the heavy lifting type muscles, the bigger muscles, the muscles that are there for force production. And these will support that by stabilizing the joints when the greater force needs to be happening. So where it's there will be sort of definite differences in particular muscles. There is a scale where certain muscles will be higher in these fibers and lower in these fibers, and there will be certain muscles that are higher in these fibers and lower in these fibers. So it's not each muscle will be 100% one and 0% of the other. There will be a scale to it. So just having that understanding and knowing that there are different muscle fiber types, when we come on to neuromuscular system, we'll be able to sort of paint a slightly better and build a little bit more depth to the muscle fiber types.